RCA 630 chassis. This is the first post-war design and the first mass-produced set by RCA or by almost any manufacturer after the war. Um, Many of these were made, and these were also licensed to other companies to sell, like Feta, Crosley. Very popular set, and very sought by collectors to work on. So I'm going to give you a little tech tip here. I was an RCA tech back in the day when I had dark hair, and I no longer have that. But when I started at the company, there were still people there that worked on these sets when they were new, and I was lucky to meet them and learn from them and remember some of their stories. So I'm going to show you something that was taught to me way back in the day by a tech named John Tabor, who went to work for RCA right after he was discharged from World War II. He is long since passed, but he showed me this about sets that roll. So you take your set and you do all your work and you recap it and everything, and you get it working, and it's a roller. After 20 minutes, a half hour, an hour, the vertical hold starts to jitter and you're constantly adjusting it and it's annoying. And what to do? Well, these sets use a circuit called an integrator. And the way it works is right here you have the sync separator, keys, the vertical oscillator, and this area right here is your vertical oscillator and integrator. And you can see that it's a network of resistors and capacitors that are very closely matched to create what we call a time constant. And most of these sets, when they were manufactured, these were mass manufactured. Everything, the tolerances on these were 20%. That means each component can be within 20% of its original value unless specified and be considered a good component. Well, let's see what we have here. So we have 22K, 22K, 8200, and 8200. What these do is they set up the rise time. I'm going to show you the waveform here now. This is the waveform for the integrator. It sets off the rise time, on time, discharge time. I'll do that again. Rise time, on time, discharge time. Then the pattern repeats itself. This time here to here, and this time from here to here, are the two time constants that are set up by the 22Ks and the 8200s. So let's take a look at what we found here. The two 22Ks that were in here, this 22K measured 30. That's more than 6,000, which is 20% of tolerance. This one measured 28,300. Again, 28K would be in tolerance. This one is out. This 8200, 9970, that's out of tolerance because 20% of 8200 is 1.64K or 1640. The only component in this circuit that was in tolerance is this 8200, which was barely in tolerance by 20 ohms. What I'm saying here is when you recap one of these sets and when you go through these and you check everything and you think that those are in tolerance, do not let it go. What I do with these is I replace them all with modern temperature stable resistors. And that will cure your problem besides obviously recapping it. This set will lock and it'll stay in vertical sync and it will not roll. And what happens, the reason this happens is because these parts, when they're out of tolerance like this, it only takes a little bit of extra temperature. These things heat up obviously to make this thing misbehave even more. And if you just do it while you're in here, just replace them besides your regular recap that you're going to do and test all your other components. The set's not finished yet. It makes for a much more enjoyable experience when it's finished. And to let you know, this circuit was eventually encapsulated into a little mini integrated circuit. They called it integrator. RCA did it. In other words, all these parts were put onto a little like a chip. It wasn't a semiconductor chip. Philco, everybody knows, and the Predictas had these in there, and they were not discrete like this one is anymore. So do this, and you won't have a roller. Stay tuned.